Hello everyone, and welcome back to Algebra 1 with Miss Betsy. Today we're going to be discussing how we multiply integers. If you are tracking with me in a text, I'm using the second edition of Algebra 1 for Christian schools. It's published by Bob Jones University Press, and this is section 1.5. If you just want to know about how you multiply integers, doesn't matter what text you have, you can learn from me just as easily. So let's pray and then we'll go ahead and get started. Father God, thank you for your goodness today. As I look at the world around me today and I enjoy this bright sun that you blessed us with, I am just reminded anew of how much you love us and how much you care for us. Father, I ask that you would help us to understand the things that you would teach to us today, that you'd help us to be diligent and disciplined in all that we would do, and that our lives would honor and glorify you. In the name of Jesus I pray, amen. Okay, lame joke for today, and I think this one is particularly lame. I'd actually heard it from my father a few months ago. I hadn't heard it for a long time. And it was particularly interesting to me. My father lives, and my mother as well, they live 1,300 miles away from me, so I don't have an opportunity to see them much, and Dad never tells jokes. So I really didn't know what to say when he said this one. So, what does a snail say when it's riding on a turtle's back? You got to get this image here. The snail's riding on a turtle's back, and he's going, whee! You know, he's having the fastest ride of his life. So let's go ahead and talk about multiplying integers. But before we get that done, let me do just a little bit of housekeeping, if you will. When I am writing, I think I've shown this to you before, but let me remind you of how I write things. Lots of you write a number 7 like this. Maybe you write a number 7 like that. That's fine for you, but it became my convention a number of years ago to put a slash through my 7. You'll find this a lot with European writing, or sometimes a lot of math teachers just slash their 7s, and there's no reason for me to tell you why. If I am talking about the variable x, which we're going to have all of the time in algebra, that's how I'm going to write an x. It's going to be sort of like a script x as opposed to an x that looks like that. And the reason, of course, that I'm doing this is because in lower level math, when we saw something that looked like this, we knew that they were asking us to say 4 times 5. So whenever I'm talking about x as a variable, I'm always going to use that script x. And matter of fact, I'm never even going to use this x anymore. So rather than using an x to indicate multiplication, as many of you have done for a long time, we're going to simply use a raised dot or parentheses to indicate multiplication. In arithmetic, you say 4 times 5. We're not going to use that x anymore. We're going to either use a raised dot, 4 times 5, or we're going to use parentheses to indicate multiplication. And I'm rarely even going to use a raised dot. I'm just habitually going to revert to using parentheses. Now, this was just multiplication using numbers. If we're going to show multiplication using these variables, this right here, when you have a number bumped right up against the variable, this actually means 4 times x. But it's going to be written, it's not going to be written 4 times x typically. It's not going to be written 4 times x. You're going to very quickly, if you're not already at this point, get to where you understand that if you have a number bumped up right against the variable, that means that you're multiplying it. See, I've got my notes over on this other side of the board to see that I cover everything I want to. One other thing as far as how written symbols look for me, just remind you that as we get into variables, we have x, y, z, a, b, and c show up very, very frequently. Make sure that I can read your z. If you're not so precise with your writing, like I'm not, even though I try to be, is that a 2 or is that a z? You will never have a question for me because I'll try and make my 2's really clear to you. But if you have the least bit of a question, my z's are always going to have a slash through that center bar as well. So I have a z and I have a 7. Okay? Now you should be able to understand my handwriting a little bit better. And I do my best to write as neatly as I can. Okay, what we're going to be reviewing right now is we have properties of multiplication that we talked about. And what mathematical properties are these statements that can be true for any value, for any number. Since we're multiplying integers, this is what we want to be talking about. First, we're going to be talking about the commutative property of multiplication. And the commutative property tells us that order doesn't matter. Commutative property of, and we are specifically talking about multiplication here. Multiplication. Make sure that, yes, you can all see that. What this tells us is the order in which we multiply numbers doesn't matter. This also works for addition as well. 3 plus 4 is 7. 4 plus 3 is 7. So addition is commutative. It doesn't matter which addend comes first. Your answer is always going to be the same. Multiplication is also commutative. It doesn't matter if we say 3 times 4 is 12, or if we say 4 times 3 is 12. The order of the factors in a multiplication problem doesn't matter. Now, catch this vocabulary here, quick review. Teacher and me can't help but review. The things that you add together, what are they called? They're called addends. The answer to an addition problem is called a sum. What are the things that you multiply together called? Those things are called factors. And the answer to a multiplication problem is called the product. So if you don't have this vocabulary, this terminology settled down for you, you need to learn it, because I'm going to be working diligently to speak the language of math correctly for you so that you learn it if you don't already know it. And I told you that we're going to be talking, the focus of this lecture is multiplying integers. Integers are positive and negative numbers, as well as 0. So our factors can either be positive or negative, which means that we're going to be reviewing what happens when we multiply a negative number, positive number together. But we're not going to talk about that right now. Not just yet. We're simply talking about the commutative property of multiplication that says no matter what values you put in here, no matter what two factors you have, it doesn't matter which one comes first. And in the language of algebra, we say that A times B is the same as B times A. So they want you to associate together the commutative property of multiplication and addition with something like, looks like this. Obviously, this one here is multiplication, and A plus B is the same as B plus A would be the commutative property of addition. Same general idea. Okay, that's the first property that they're talking about in your text. This is on page 20. And what you need to make sure, I'll remind you of this, is every time you have a section that you're studying in math, I'm going to go through and teach it, but I am not going to read the book to you. I assume that since you're in my Algebra 1 class, you know how to read and you have the ability to open your book up and read through that material in there. You need to do that. But it's not so easy sometimes to read a math book, because you read that a lot differently than you would read a history book. But you do need to go through the material, and if you find something that is confusing to you or doesn't make sense to you, that's something for you to write yourself a note, jot yourself a note, and ask me about that when we have our face-to-face time on Fridays. Okay, the next property that I want to talk about is the associative property. In this chapter, we are specifically talking about the associative property of multiplication, but it also works for addition as well. These properties work for multiplication and addition. They do not work for division and subtraction. So first we had commutative. The second property that we have is the associative property. Use the first 5 letters of this term, of this word, to abbreviate it, please. If you're going to do abbreviation, I just appreciate that. Okay, what the associative property tells us is that when you are multiplying together 3 or more factors, it doesn't matter which 2 factors you multiply together first. And here I am going to use a raised dot so that I can illustrate what I'm trying to do here. And if I can keep it with numbers instead of variables, that will help. If we have 3 times 4 times 5, we're going to follow our order of operations that says do the multiplication within the parentheses first. So 3 times the quantity, 4 times 5 is 20. 3 times 20 is 60. In this problem here, we grouped together the final 2 factors first. The associative property tells us that it does not matter which 2 factors you multiply together first, you end up with the same answer. Here we group the first 2 factors together. 3 times 4 is 12, and then we multiply 12 times 5 to get 60. This is called the associative property. It says, it doesn't matter how many numbers, how many factors we're multiplying together, 3 times 4 times 5 times 10 times 1,000, you can only multiply 2 numbers together at one time. We can't, now, as you practice multiplying, you would know by looking at this that that's 60, 3 times 4 times 5 is 60, because your mind gets going fast enough, but what your mind is actually doing is first saying 12 times 5, or 3 times 20. So you can only multiply 2 numbers together, 2 integers together at one time, and it doesn't matter what way you group the factors together. That's the associative property. And then you can actually combine the associative property and the commutative property. I don't think they're going to do this in your text, but we have 3, 4, and 5. First, we're going to change the order around a little bit and look at that. What am I doing wrong? 3 times 5 times 4. Now I'm not even going to group them. I'm just going to multiply them in order. 3 times 5 is 15 times 4, which gives us 60. You see here we have 3 separate ways that we've grouped these numbers together. We come up with these factors together, and we arrive at the same answer each time. This right here is the associative property. It doesn't matter which way you group, which 2 of the factors you multiply together first. You add in the fact that order doesn't matter, and you have yet a third way that you can group these factors together. This is called the associative property of multiplication. You have to know that the commutative property means that order doesn't matter. Which factor or which add-in comes first doesn't make a difference to the answer. You have to know that the associative property means the way in which you group multiplication, where those parentheses go. That does not affect the answer either. See, now we have one that's a little bit different. Actually, it's a lot different, but it's a very, very, very valuable property. It's not so valuable with distributive, not so valuable when you're just working with multiplication of integers, but it's very valuable when you are multiplying variables. And it is called the distributive property of multiplication over addition. This is sort of a real specific technicality here. If you just remember for me the distributive property, you'll know what I'm talking about. And before I go into giving you an example with variables, let me do again an example with a number. Let's say that we have 4 times, let me see, which way do I want to do? Distributive property of a product. Okay. We have this problem here, and it says 4 times 14. And you notice I don't have parentheses around that first 4. That's because it's not necessary. The 4 is bumped right up against the parentheses. What's 4 times 14? Well, that is 56. You know, maybe you wrote that out to the side. Maybe you did the multiplication in your head. Maybe what some of you did was you said, well, 4 times 14, I can break that apart, and I can say that's the same as 4 times 10 plus 4 times 4. 4 times 10 is 40. 4 times 4 is 16. And you see that you have arrived at the same answer. 4 times 14 is 56. 4 times the quantity, 10 plus 4, takes a few more steps, but you end up with the same answer. And this is what they call the distributive property of multiplication over addition. And what it's saying here, we have 2 different ways of approaching the same problem. It says the product of a number, product of 2 numbers right here, is the same as taking the product of the sum. And I don't care if you can put this into words. What I want you to do is see that you can break something apart into 2 or more parts. Now, in the world of multiplication of numbers, if I have 4 times 14 and I'm going to physically write out the steps, I am not going to break it apart this way. If I actually am writing something out, I'm going to write it this way. 4 times 4 is 16, carry 1 is 56. This is going to be the type of work that I would use to show multiplication. I wouldn't show it this way, but what we want you to see is that the method works to get an answer. And when you get to where you are using variables frequently, you're going to use this distributive property all the time, because, and this is why. What is 10 plus 4 equal to? Well, 10 plus 4 is equal to 14. So most of the time you're not going to want to do this unless you use that for mental arithmetic, which I do all the time in my head. If I'm trying to multiply 12 times or 8 times 72, I might think 8 times 70 is 560, 8 times 2 is 16, so it's 576, if in fact I did it right. So I might use this, break it apart in my head when I'm doing mental arithmetic. But if I'm writing something down, I'm going to go ahead and combine 10 plus 4 to be 14 before I multiply it. And that's because you can add 10 and 4, can't you? But what if you had, I'll just go ahead and show you this. It'll be a review for some of you. It'll be new for others of you. What if you had 4 times the quantity A plus B? Then we have something that is just a little bit different, because our order of operations tells us add together what you have inside the parentheses. Well, can you add A and B? No, you can't. You can add 10 and 4 to get 14, but you cannot add A and B to get something. So this is when you use your distributive property, and you would say that's the same as 4 times A plus 4 times B, which is 4A plus 4B. If that's meaningful to you right now, just use it as a reminder of what the distributive property is. If it isn't meaningful to you, don't even worry about it. We'll learn about that soon enough. So we have seen the distributive property of multiplication over addition. We've seen, which is what we just saw right now. We have seen the commutative property, which tells us that the order in which you multiply, the order which comes first, doesn't matter. And then we also had the associative property, and that told us that the way you grouped factors together did not change the result. For our fourth property that we have the multiplicative, let me make sure we're still in there. We have the multiplicative identity property. Identity properties are those properties that give us rules for when you manipulate a number or a variable, but you don't change. By the time you're done with that manipulation, the original number hasn't changed. Multiplicative identity looks like this. A times 1, look at my distributive property, is equal to A. 1 times A is equal to A. When what this is telling you is you take any number and you multiply it by 1. Take any number, multiply it by 1, and you don't change the original number. Or if you multiply 1 by any number, you're still going to have that original number. That's the multiplicative identity property. Multiply anything by 1 and you don't change it. You say, okay, I want to really grow this money that I have here in my piggy bank, and I have $10, and I'm going to multiply it by 1, and I'm still going to have $10. Doesn't change that value at all. Let me back up to the distributive property, because I was giving you the letters, giving you the algebra that defines the distributive property, and I didn't do that. The distributive property says that if we have A times the quantity B plus C, that's the same as A plus B times, A times the quantity B plus C is the same as A times B plus A times C. Now go back to this example that I had. If I had 4 times the quantity A plus 4, that was the same as 4 times 10 plus 4 times 4. This is the pattern that you're going to use. It's the formula or the recipe that you're going to use every single time you need to distribute something where you cannot combine the terms that you find inside the parentheses. Here, it's not necessary. The distributive property works here, 4 times 10 plus 4 times 4. But most of us are going to say, before I solve this, I'm going to solve my addition problem here inside the parentheses so that I end up with 4 times 14. However, if you have 4 times A plus B, you cannot combine that. You cannot combine the A and the B together to get something meaningful. So the distributive property is definitely necessary when you are dealing with variables. Okay? Distributive property. So we have the multiplicative identity, the distributive property, the associative property, the commutative property. This should be review for you, but they're covering it again on page 20 and 21 of your text. If perchance this is new, it needs to be up here and totally understood right away so that you're up to speed with this language of algebra. Now, back to what we're actually doing in this section, which is multiplying integers. On page 21, it gives you in the middle, and I've been dealing with allergies, I think I'm getting ready to sneeze, I apologize. In the middle of page 21, it gives you a very technical definition of how you multiply integers. I want you to read that. I want you to do your best to comprehend it. It deals with absolute value. In light of the amount of time that we have in a video-driven class where I meet you one day a week, I'm not going to get all bogged down in that. I'm going to just simply tell you what happens if you are multiplying factors. Integers can be positive or negative. There are two ways, two different signs, three different ways the signs of those numbers can be paired together. Both of the numbers can be positive, both of the numbers can be negative, one number can be positive, and one number can be negative. Those are the only three possible combinations of factors. Both of them are positive, both of them are negative. One is negative, one is positive. And you say, well, no, there's really four different ways. Well, no, not really. Our commutative property tells us that the order in which we multiply factors together doesn't change the value. So yeah, the order can be different here, but it's still the same thing. You've still got one of them positive and one of them negative. So, I want you to simply memorize what happens. You already know what happens if you multiply together two positive numbers. Your answer is always going to be positive. It's sort of like a well, duh. 4 times 5, and there I put the answer already. 4 times 5 is 20. And you understand naturally, because you've been doing this for so long, that we're talking about positive numbers here. You don't have to write that that's a positive 4. You don't have to write that it's a positive 5. You don't have to write that that the product of 4 and 5 is a positive 20. You know it's positive. So, multiplying integers together is easy. This is rather a lame illustration. But let's say that you have two negative signs coming together and they are going to crash. You've seen some horrible pictures of train crashes, or you've crashed your own trains when you were little. What happens? They don't usually just stay like that. They sort of get all crumbled up on each other together. Put it over there. You have two negatives coming together, a negative times a negative. They crash and they become a positive. Negative times negative is positive. If you want to know the theory behind it, which I'm not going to teach you, that's on page 21. Positive. If you have two negative factors, negative 2 times a negative 4, that is a positive 8. The only other option that you have is where you have one factor negative and one factor positive. And those are always going to be negative. Negative 2 times a positive 4 is a negative 8. 2 times a negative 4 is also a negative 8. These are the rules that you follow. Your book tells you the why behind what actually works out in real life. When you have factors, a pair of positive factors results in a positive product. A pair of negative factors results in a negative product. Mixed factors, positive, negative, the product is always negative. Okay, let me take just a second and that you don't even really need. I'll write some numbers here. If we have negative 3 times a negative 2, if we have 4 times a negative 5, if we have negative 6 times 3, negative 8 times a negative 2, what do we have? We have two negative factors, train wreck, positive. Negative 3 times a negative 2 is a positive 6. 4 times a negative 5, one factor is negative, the answer is always negative. 4 times 5 is 20, but it's negative because we have one negative factor. Negative 6 times 3, one negative factor, the product is always negative. It does not matter which factor is negative, if it's the first factor or the second. As long as you have one negative, one positive factor, your answer will always be negative. Again, here, negative 8 times a negative 2, two negative factors. The product is a positive 16. And I won't insult your intelligence by saying, here's the example of what happens when you multiply two positive integers together, you get a positive answer. Okay? That is section 1.5. Go through, work that. The questions that I might anticipate you having in class when you see me face-to-face would be, how do I translate from English into arithmetic? And we'll be working on those. Have a good week, and I'll see you next time.